Hello everyone and welcome back to my channel Let's Learn Together. So today we will be solving session 7, 8 and 9 of science exercise book of class 9. So there are a total of 5 activities in this session. So we will go through them and see their answers and try to understand the answers more or less. So let's start. Let's see what is the first question. Look, I have highlighted the main part of the questions for you. So, what type of handle of the okay? Suppose you're returning from a store with a shopping bag. What type of handle of the bag will reduce your pain, thick or thin? That means, look, when we go to shopping, we carry shopping bags, right? Like cotton bags or any other sort of bag. So, if the handle of that bag is thick, then what kind of pain do you feel? Or if the handle is thin, what kind of pain do you feel? That means in which case do you feel more pain? Let's say you have done a lot of shopping. Okay, now when you will carry the bag, you have to observe that is the thick handle giving you more pain or the thin handle giving you more pain, and why is that? You will find a difference, and why is that? So basically you have to write it, and there is another part of this question, that is, let's think about your school bag. If the strap of the school bag is thin, will it be more or less difficult to carry the bag? That means our school bag, it has a strap, right, that we carry on our shoulders. So if that strap is thick, then what kind of pain do you or, I mean, how much pain do you feel? Or if it is thin, then how much pain do you feel? Obviously, in case of the straps or the handles being thin, we will feel more pain. But if it is thick, then we will feel less pain. That is because of the concept of pressure. We know that pressure equals to force by unit area. That means, like, look, if the unit area where the force is being applied is more, that time we will understand that if unit area is more, that time we will understand that pressure applied over that area will be less. But if unit area is less, then we can understand that pressure applied over that area will be more, because pressure and unit area, or simply area, has an inversely proportional relationship. Okay, so you have to write that over here in a brief way, basically. And then we have a math here, that if the surface area of each wheel of the scooter mentioned in the previous example uh, is 10 square centimeter, could you find the pressure exerted by the scooter on each wheel? Will the pressure on that wheel remain the same if the scooter is loaded on one wheel during the repair? That means, look, from one of the previous examples, we saw that one question was about scooter and bicycle. Yeah, this is this one. Okay, so look, from here we have to take some data for that question. Basically, here the mass of the scooter is given this 110 kg. Oh, sorry. Look here, the mass of the scooter is given 110 kg, and we don't need anything else to take from here. Okay. Now look, here. The new data that has been given is the area of each of the wheel is 10 square centimeter. Right. That means এই যে স্কুটারে একটা স্কুটারে বেসিক্যালি দুইটা হুইল থাকে, তাই না? তো দোনোটা হুইলের যে এরিয়া বা যেটুক এরিয়ার সাথে ওরা কোনো সারফেসের সাথে কন্ট্যাক্টে থাকে, যেটাই হোক, সেটা হচ্ছে 10 স্কোয়ার সেন্টিমিটার, তাই না? সো কোয়েশ্চেনটা যেটা জিজ্ঞেস করেছে সেটা হলো যে এই প্রত্যেকটা হুইল, হ্যাঁ, এই যে ফুল স্কুটারটা এই দুইটা হুইলের উপরে আছে। তো এই স্কুটারটা এই দোনোটা হুইলের উপরে কতটুক প্রেসার এক্সার্ট করতেছে, কতটুক প্রেসার অ্যাপ্লাই করতেছে, ঠিক আছে? এখন বলেছে যে ইচ হুইল মানে একটা হুইলে কতটুক প্রেসার অ্যাপ্লাই করতে মানে করছে স্কুটারটা, সেটা এখানে চাওয়া হয়েছে প্রথমে। তারপরে দেখো, will the pressure on that wheel remain the same if the scooter is loaded on one wheel during repair? That means এখানে দেখো, এখানে আবার বলা হচ্ছে আমরা তো ফার্স্ট পার্ট অনুযায়ী এক হুইলের জন্য স্কুটার কতটুকু প্রেসার এক্সার্ট করছে সেটা বের করেছি, তাই না? এখন বলতেছে যে ফুল স্কুটারের লোডটা যদি একটা হুইলের উপরে থাকে, আগে তো দুইটা হুইলের উপরে ছিল, তো স্কুটার যে টোটাল প্রেসারটা এক্সার্ট করতো ওইটা দোনোটা হুইলের মধ্যে ডিভাইড হয়ে যেত, তাই না? কিন্তু এইখানে কি হয়েছে, রিপেয়ারের সময় হয় কি যে ধরো আমরা যদি একটা হুইল রিপেয়ার করতে চাই তাহলে স্কুটারটাকে একটু মানে স্কুটারের ওই পার্টটা একটু উঁচা করে দেই, তখন হয় কি পুরো যে স্কুটার সেটার ওয়েটটা একটা হুইলের উপরে পড়ে যায়, তাই না? তখন তো আর দুইটা হুইল থাকছে না ওয়েটটাকে ইকুয়ালি ডিস্ট্রিবিউট করে নেওয়ার জন্য। দ্যাটস ওয়াই তখন কিন্তু সেই একটা হুইলের উপরে বেশি প্রেসার অ্যাপ্লাইড হবে। তো এইটাই আমরা ম্যাথমেটিক্যাল ক্যালকুলেশনস দিয়ে এখানে প্রুভ করব। ঠিক আছে, তারপরে নেক্সট ক্যালকুলেশনটা হলো average density of air is 1.3 kg per meter cube, and air pressure in normal environment is 1,1325 Newton per square meter. Could you figure out the height of Earth's atmosphere from this information? That means এখানে আমরা জানি যে প্রেসারের না ওয়েট এখানে কি চেয়েছে, বেসিক্যালি এখানে হাইট অফ আর্থস অ্যাটমসফিয়ার চেয়েছে, ঠিক আছে? এন্ড ডেটা দেয়া আছে অ্যাভারেজ ডেনসিটি, দ্যাট মিন্স ডেনসিটিটা দেয়া আছে এখানে, প্রেসার দেয়া আছে, এন্ড আমাদের কাছে হাইট চাওয়া হচ্ছে। ঠিক আছে, তো আমরা জানি অ্যাজ পার প্রেসার ফর্মুলা পি ইজ ইকুয়াল টু এইচ রো জি। রো মিনস ডেন্সিটি যেটা দেয়া আছে, অ্যান্ড এইচ চাওয়া হয়েছে, জি এর ভ্যালু ফিক্সড 9.8 মিটার পার সেকেন্ড, অ্যান্ড যে প্রেশারটা সেটাও দেয়া আছে। তো আমরা কিন্তু ইজিলি ওই ফর্মুলাটা দিয়ে এখানে আর্থস অ্যাটমসফিয়ারের হাইটটা বের করে ফেলতে পারবো। আচ্ছা, এখন নেক্সট কোয়েশ্চেনটা হলো, থিঙ্ক ওয়ান্স whether we feel more or less wet during swimming. Why? Write your answer in the space below. আমরা দেখো যখন আমরা সুইম করি তখন কি হয়, আমরা একটু লেস ওয়েট ফিল করি। লেস ওয়েট ফিল করার মানে কি আসলে? ওয়েট বলতে কি বোঝানো হয়? ওয়েট বলতে বোঝানো হয় যে আর্থ আমাদের মানে আর্থ আমাদের কতটুকু গ্র্যাভিটি দিয়ে পুল করছে, তাই না? মানে গ্র্যাভিটি তো বেসিক্যালি ওয়েট। দি পুল অফ গ্র্যাভিটেশন দ্যাট উই ফিল টুয়ার্ডস আর্থ সেন্টার ইজ বেসিক্যালি ওয়েট, তাই না? তো আমরা যখন সুইম করি তখন আমাদের মনে হয় কি যে আমাদের বডির কোনো ওয়েট নেই, মানে আমাদের মনে হয় যে আর্থ আমাদেরকে ওরকম ভাবে পুল করছে না, ঠিক আছে? পুল করছে না, এটাকে কাইন্ড অফ ওয়েটলেসনেসও বলা যায়, কিন্তু এখানে আমরা ওয়েটলেসনেস বলবো না, এখানে আমরা বলবো যে উই ফিল লেস ওয়েট। ঠিক আছে, তো এটা কেন হয়? আমরা যখন সুইমিং করি তখন আমাদের কেন মনে হয় যে গ্র্যাভিটির পুলটা আমাদের উপরে কম হয়ে গেছে? এটা কেন? তো সেটার অ্যান্সার আমরা এখানে লিখবো। তারপরে দেখো আরো একটা ম্যাথমেটিক্যাল ক্যালকুলেশন দেয়া হয়েছে যে the average density of the human body is 985 kg per cubic meter. Density of fresh water is 1000 kg per cubic meter, and the density of dead sea water is 1240 kg per cubic meter. If you step into a swimming pool filled with fresh water, what percentage of your body will be drowned? If you were to swim in the Dead Sea, what percentage of your body would float? So, look, we know that when an object is immersed in any liquid, that time that over that object, two forces basically act. একটা অবজেক্টকে যখন আমরা কোনো মানে কোনো যে কোনো লিকুইড ধরো পানির মধ্যে যখন ইমার্স করি তখন এই অবজেক্টের উপরে দুই ধরনের ফোর্স অ্যাপ্লাইড হয় বা দুই ধরনের ফোর্স কাজ করে, ঠিক আছে? একটা হলো এই অবজেক্টটার নিজের ওয়েট যেটা, and the second one is buoyant force. Now what is buoyant? It's buoyant or buoyant, anything, both are all right. So what is buoyant force? Basically buoyant force is the force that is the upward force that is exerted on any object that is immersed in the liquid. Okay, and that buoyant force, according to Archimedes' principle, that buoyant force is equal to the weight of the displaced water. As we know that when any object is immersed in a liquid, that time that object displaces a particular amount of water, right? Which results in the rise of water's level. So that specific amount of displaced water's weight is equal to the buoyant force that will be applied on this object. Okay. So if that buoyant force is more, then the object's weight, that time the object will float. And if the weight of the object is more than the buoyant force, then this object will sink. The object that is immersed, that will sink. Now, the thing is that this buoyant force and weight, let's say, both depend on the objects and the liquid's density. Okay, here two densities of the liquids, which is fresh water and dead sea water, are mentioned. Fresh water's density is 1000 kilogram per meter cube, and density of dead sea water is 1240 kilogram per meter cube. Okay, both these are the densities of the liquids, and the density of the human body which will be immersed in that liquid is 985 kilogram per cubic meter. Okay, now see, um, if we compare these two densities with the density of human body, then we can see that human body's density is less than both of these densities, right? So in both of these waters, the human body would float, because as the density of human body is less than the density of fresh water and dead sea water, that means the weight of the weight of the human body will also be less. And as the weight of the human body will be less, that means consequently the buoyant force which will be applied by these water bodies would be more on that object, and as the buoyant force will be more, so they will obviously float. Now, in both of these water bodies, the human body will float, but the level of their floating would vary, because fresh water's density is less than dead sea water's density, right? So we will see that percentage of the part of this human body which will be submerged in water would be more in fresh water and would be comparatively less in the dead sea water. Okay, because in the dead sea water the buoyant force is more. So, due to as the buoyant force or the upward force is more, that means the object will be pushed upwards more, and that's why it will be floating. It's part of like the part that will be submerged, that will be less in comparison to this case. So now we will see how this is going to be calculated. Okay, so they basically said that if you were to swim in the Dead Sea, what percentage of your body would float? Look, there is a specific formula to determine that how much percentage of our body will be drowned. Okay, and if we find that for both fresh water and dead sea water, then we can understand, then we will get our answer. But look, for dead sea water, they told to find out what percentage of your body would float, right? But through the formula we can find out that how much part would be submerged, not floated. So that's why what we will do, we will just subtract the submerged part or the submerged percentage from 100, and then the part we will get is the floating part. So all right, I think you have understood all the questions. Now we will go through the answers. All right, so this is the answer to the first question, which was about the strap or handle of your school bag or shopping bag, that for what sort of handle your pain would be less, if the handle is thick or thin. So we know that when the when the area is less, at that time the applied pressure is more. That means if the handle is thin, that means its area is less, right? So it will create more pressure in our hand in that specific area, which will cause more pain. But if it is a thick strap, then the pain will be less, because the applied pressure would be less because of the more area, right? So this is written here. All right, now the next question was a calculation, right? So let's see it. So this is the first calculation, as you can see here. Look, as per the question, the scooters, this scooter has two wheels, right? So both of those wheels areas were given, and they told you at first to find out the pressure that was applied by the scooter on each of those wheels. So look, the whatever force is acting on those two wheels, or whatever force that scooter has, must be divided by two if we want to find that what amount of force is being applied on each of the wheel, because there are two wheels, right? That's why we divided the whole force by two, and we got 539 newtons. And then as we have the force applied per wheel, now we can find out the pressure. So we did. Then as the area was in 10 square centimeter, that's why we converted it into 0.001 meter square, and thus the answer came 5,39,000 pascals. So this is the pressure applied on each of the wheel by the scooter. Now, afterwards in the question, they told you that in case of repairing, when all the force of that scooter will only fall on one wheel, at that time, what will be the pressure over that wheel? So look, now the force, the total force or the total weight of that scooter is falling on one wheel, not on two wheels, right? So we have to divide the surface area of that one wheel by the, I mean, we have to divide the total weight of the scooter by the surface area of this one wheel. So we did it, and the answer came 10,78,000 pascals. So the pressure on each wheel under normal conditions is this, and if the scooter is loaded on one wheel during repair, the pressure on that wheel is this. So I hope you have seen the answer properly. Now we will go to the next question, which was yeah. So this is another mathematical calculation. Let's see what the solution is. All right. Okay. So this is the second calculation. As they told you to find out the height of Earth's atmosphere, and both density and gravitational acceleration and pressure has been mentioned in the question. So you can rearrange this formula into this, and you will then just place the values and solve the math. And ultimately, the answer you will get is 7,956.5 meters. That means this is the height of Earth's atmosphere. I guess you have seen this answer as well. All right, now we will go to the next question. That is, okay, this was, think once whether we feel more or less weight during swimming. Why? Write your answer in the space below. That means when we swim, that time we feel that there is a lack of weight. Weight, that means we feel a lack of Earth's attractive pull towards us. Okay, now why is that? That is because buoyant force. Because when any object or when any individual is immersed in water, at that time water exerts an upward force towards it, which acts opposite to that object's weight, right? That's why, due to that upward force, uh, some of our weight, we feel like some of our weight is reduced. It doesn't happen in real, but we feel like that. Okay, it reduces our apparent weight and makes us feel lighter in the water. All right, now let's see the next question, which is also a mathematical calculation. Now we will be solving this. All right. Okay, so this is basically the calculation 3. This is very easy, as far as I told you before, that there is a specific formula to determine the percentage of what portion of any immersed body is drowned. So this is the formula that you have to divide the density of that body which is immersed by the density of the liquid. So in this regard, as we are calculating for fresh water, then this is the density of fresh water multiplied by 100 is being multiplied here because we want to find the answer in percentage, right? That's why. So look, in fresh water, the percentage of human body that is drowned is 98.5%, right? And now for dead sea, the same calculation will happen, but here look, we are subtracting this part from 100 because they wanted the percentage of floating, not of drowning, right? That's why whatever result we will get from here, we have to subtract it with 100. Look, this is the thing, and they subtracted it by, from 100. So then the answer was, look, 100 minus 79.4. 79.4% is, let's say, the portion that was that was drowning, or that was submerged underwater. And then by subtracting it, we got 20.6%. This value is the portion that was floating in above, no, yeah, at the top of the water. Look, therefore, 98.5% of your body will be drowned in fresh water and 20.6% of your body will float in the Dead Sea. All right, I think you have properly seen all the calculations. Okay. So our this session is done as well. Session 7, 8, 9 is completed. In the next video, we will be completing the very next sessions, and there are some very interesting things in there as well. So, all right, for today's video, that's it. I hope you found this video informative, and if that is so, please like, share, and subscribe. And if you need any sort of improvements in these videos, then let me know in the comment section. For today, goodbye. We will meet in the next video.